You got the screen, Mark? Yeah.
Yeah, just get you on 1 second.
Over to you then. I'll mute myself. Enjoy the show.
Let's move that there. Right. Good afternoon, everybody. It's Mark Covill here for HK Technologies, Regional Sales Manager, part of the Engineering Technologies Group. And within HK Technology, we have 6 core parts of the business. We have balance systems, EDM technologies, additive manufacture, laser marking, super finishing, and gear grinding. It's the gear grinding that I'd like to talk about this afternoon. So our partner, when it comes to gear grinding with HK Technologies, is a company called Kapp Niles, a German company that was founded in Coburg in 1953. Now, for Graham Thomas's purposes, Coburg is also the birthplace of a certain Prince Albert. So I'm sure he'd like to visit there at some stage. So the second part of the business is the Niles parts of Kapp Niles, which was founded in 1898. Niles ended up as being behind the Berlin Wall when Germany was split after the Second World War, and when the wall was actually brought down in the 90s, they found that under capitalism they struggled as a business, and so they were purchased by Kapp in 1997, and the company Kapp Niles was founded. The way the two businesses worked previously, Kapp used to produce gears up to a size of diameter of 1 metre, and Niles would produce gears above 1 metre. So by bringing the two companies together, what actually happened is you had a company which now offers a wide range of gears, from the smallest to the biggest capacity that's out there. 2017, Kapp Niles also then founded a separate division of metrology, gear measurement. So from being a global market leader in the manufacture of machine tools and finishing tools of gears and profiles, by bringing in metrology, they now become a total turnkey supplier for gear grinding. HK have been working with Kapp Niles since 1997. So what is a gear? So a gear is a wheel that works with other toothed wheels to alter the relation between the speed of a mechanism and its driven parts, the torque of a mechanism and its driven parts, or the direction of drive and force within a driven mechanism. So to put that into some sort of perspective, when you drive your car, if you want to go faster, you change the gears. So what that does is, by driving through the system on changing the speed of the main driving parts, the smaller gears, you can alter the speed of the car. In the same way, by going down the gears, you can increase the torque from the car. You see down the bottom here, we also have a little animation which shows how we can also use gears to change the direction of force within a driven mechanism. So gears can be used to change speed, torque, and force within a power source. Just give some examples of some types of gears. Most common gear is a spur gear. It's the most simplest form of gear. Parallel teeth, very good for transforming high power, a lot of torque in spur gears. But once you get to high speeds, they tend to become very noisy. So what was developed over the years is things like helical gears, where, as you can see on here, the teeth are now, rather than being cut straight, are now at a helix angle, slight angle. What it means is that when they mesh together smoothly and more quietly, so they run quieter than standard spur gears. And so they tend to be one of the main developments that's happened in gears over the years. So, as I said before, you can change speed of gears, and you can also change direction of force within gears. So the other examples you see are the rack pinion, which used to be standard in steering on cars, for example, in the past. It's using a change of direction, and also the bevel gears, mitre gears, and all those, the direction of force is being changed using gears. Now, most of the gears that you see on this example here are what we call external gears. In other words, the teeth are all on the circumference, the outer circumference of the gear. Down the bottom here, we also have an internal gear. It's not a very good diagram, I'm afraid, but the teeth on this particular gear will be shown internally. So the internal ring of this gear would actually make the teeth up on an internal gear. So just some examples of different types of gears that are out there. So how are gears produced? So initially what we do with the gear is from the solid, we then produce what is known as a gear blank. So blanking operation gears can be produced in several different ways, either gear forming, milling, broaching, skiving, hobbing, even wire EDM. I think as we move forward, what will become more and more relevant is some additive manufacture in the process of manufacturing gears. Gears can also be ground from solid if they're small gears. It's a very slow process, a very expensive process. It's not that common, but it can be done. So once we produce the blank from the gear by using, could be any of these processes, the next step is we need to finish the gear, and this is done by gear grinding. But why do we grind the gears? So gear grinding is a way of producing the finished gears, and it's done through an abrasive process, done through an abrasion. Small pieces are removed at each time, so we're not removing massive amounts of stock at each time, we're removing small amount of stock, so it doesn't affect the overall integrity of the material that the gear is produced from. Gear grinding also ensures that proper creations of gear teeth, so in other words, the gear geometry is produced to the standard that we want it to produce at. And the main benefits of grinding gears are, as I just said, better geometry, that the gears mesh together more effectively, and this is the way the two teeth come together on the gears. There's a more stable operation. We don't want gearboxes that are clanky, so it's more stable. Can manage greater loads, and it also gives a longer life. But one of the key points moving forward, especially with the development of electric vehicles, is things like quieter gearboxes. As we start to lose engine noise, then we want to not try and hide all the noises that we can with the gear, with the engine noise. It becomes more important that we produce quieter gears. So how are gears produced? Two basic methods, that we use in gear production. The first one is generating grinding. Now, generating grinding is where we use a grinding worm, as you can see on the left-hand side as you look at the screen here. And this meshes with the gear blank, and the two then move in simultaneously, and the abrasive action of the worm grinds the gear. Okay, we've got two examples here, and I'll come back to why we've got the two in a moment. The second process is profile grinding. So profile grinding is an individual wheel where we grind each tooth again individually. So the tooth is ground, the wheel is then withdrawn, the part is indexed, and the next part is then ground. The next tooth is then ground. So with profile grinding, we can grind not only external gears, but we can also produce, as you can see in the diagram down here, internal gears. So you'll notice on the diagram here, we have two different coloured wheels, and down here we've got a key which is showing dressable and non-dressable tools. So what's the difference between a dressable and a non-dressable tool? So a dressable tool is basically a tool that can be reprofiled within the machine. So as the worm is grinding the gear, or the profile grinding wheel is grinding the gear, it obviously takes damage itself, starts to lose its own form and profile. So with a dressable tool, we're able to, within the machine itself, to redress that particular tool. So an example here, we have the gear that's being cut over here on the left-hand side, the grinding wheel over here on the right-hand side, and this wheel here is redressing the grinding wheel to bring it back to its original form. Okay, so that's how we can do with the dressable tools. The non-dressable tools, at the end of their life, they're either sent back for the manufacturer or they are binned. They can't be redressed within the machine itself. So to give just an example of generating grinding, there's a little animation here which is from Kapp. The KX500 machine that you can see is actually capable of both generating grinding and profile grinding. But on this particular example, we're going to look at generating grinding. I'm just going to skip it forward a fraction. So we can see now we've got the parts of the gear here, or the gear blank, on the left-hand side, and over here we have the generating wheel. So you see the two mesh together, and then what you'll see is as the two turn simultaneously, that part that's moving across there would normally be the lubricant that's put in place. Now you see now that the gear grind is taking place with the two parts meshing together. So the part now is rotating continuously, as is the grinding wheel. So that's the part of generating grinding. With any of the grinding processes, we normally finish off with, that's a bit too far there. Sorry, with a check on the gear. So all the machines offer internal checking for the gear. So once the process is finished, we can then check the gear with a Renishaw probe before it being removed from the machine. So that's the generating grinding. So profile grinding, for this example, I've got a machine which is actually on drives up in Chesterfield. And if I start the video, and then again, I'm going to skip forward a bit to the relevant part. So you'll see now that rather than a worm wheel, we have an individual wheel. So this wheel is now going to cut into the individual tooth, grind that tooth, and from there, it will then move on to the next tooth. So the part will rotate and the wheel will be brought back in again. So I think we can get a close up on that. I'll jump into there so then you can then see it closer up. So again, once it's moved, the part is then rotated and the wheel is brought back into contact with the part. And again, at the end of the process, we have the Renishaw probe again, which we can bring in to check the profile of the gear. So those are two main types of gear grinding which are used. They both have certain limitations. Generating grinding, as a maximum generating grinding, we can do up to gears of 1.2 meters, from 8 millimeters to 1.25 meters. And profile grinding, we can actually go up to gears of 8 meters, example which you can see on the side over here. There are generating grinding, as you would have seen from that process, is a far quicker process than profile grinding. Profile grinding has the advantage of producing better quality gears. So you've got the trade-off against one against the other. So when you look at things like automotive products, the likes of, say, Audi, VW, where they're producing massive amounts of gears, then the generating grinding profile is the way they tend to go with that. When you're looking at things like high-end motorsports, aerospace products, then that's when you look at the profile grinding setup for that type of production. So what I do now is I'm just going to go through the machines in the range. It's quite an extensive range of products, as you can imagine, when we've got a capacity from 8 millimeters right the way up to over 8 meters. And I'll just skip through these fairly quickly so you've got an idea of what we've actually got within the range of products. So we start with the generating grinding machines. The KN3P and the KNG Expert. So the first thing I want to point out on these is any machines that have this KNG at the start here. This is Kapp Niles' new gear grinding technology. So it's called KN Grind technology. And it's a new programming system that they're starting to introduce to the machines in the range over the coming years. So some of the machines like the KN3P and the KNG Expert already have this new technology, but it will be introduced to others in the range as we move forward. So the KN3P Ready is an entry-level machine, ideal for job shops, etc. Small to medium batch work. As you see, it's very limited in size, 320mm capacity in tip diameter. The KNG3 Expert, the KNG Expert is then a step up from this, and we start to now get automation. So we now have a conveyor loading system within the machine, which is then fed into the machine with a pick and place robot inside the machine, or a revolving spindle inside the machine. So the gear is picked up off from the conveyor, placed onto the working area and the spindle there, and then that rotates back round once the part is finished. So we've got automation within the machine. So we're now starting to look at a higher level of volume of production than for the KNG 3P machine. So the KX series of machines, again, these are generating grinding machines, and these two machines are developed specifically with automotive industry in mind. So the KX dynamic machine has an integrated loading and unloading within the machine, and the part is actually loaded directly onto the spindle, and the spindle then enters the work area already accelerated. So as the spindle comes in, we're not waiting for it to start, it's coming in, the contact with the driving worm is instantaneous, and the grinding process starts straight away. Take that to a next level, an even higher level of production, the KX Twin series. So for this series of machines, we've actually got twin spindles. So we're not waiting for the one job to finish while we're loading the second part up. The rotating table has two spindles, both working spindles, so that as one part is being finished, the next part is then being brought straight into the work area and can be processed straight away. So again, high levels of production in terms of these machines. There is a third option on this. We've got the HS on here, which is a high-speed spindle option, which can also be used for using very, very small wheels down to 55 millimeters, producing smaller parts. So to move on to the profile grinding products. So again, we have an entry-level product, the KNG 320. This is, I say, entry-level machine, less than 500,000 euros. The machine is delivered pretty much intact. It's a plug-and-place type machine, ideal again for job shops, for people who are just getting into gear grinding, maybe want to just bring it in-house for the first time. And the limitation on this machine is it will do external gears only. You've not got the possibility for doing profile grinding for external gears on this particular machine. The ZE series machine is a step up from this, and this was the machine that you would have seen in that video earlier on from On Drives. This is the machine that they have there, ZE 400 machine. So this offers you internal and external grinding, very high precision in terms of the parts that are produced, and is ideal for prototype and very low volume work. So your general job shop, gear grinding, gear producing job shop will use this type of machine. So if we move up now in terms of profile grinding to the larger machines, so we're starting to move up to these sort of machines that may be used for things like the gears that are driving a submarine, or gears that are driving a large frigate or other marine vehicle, or even some of the large earth-moving machines that you may get in quarries and things like that. Then you would then move to gears of the size that can be produced on the 10p master and the 12p master. These gears are up to 1.25 meters, but we can start to get bigger than that. They're still very high because of profile grinding. They're very high precision gears still. And again, we're able to produce these gears using internal, both for internal and external gears. The KNG, as I said before, means that we've got the new KN Grind software on this machine. And it really, so the KNGP Master Gear gives you all-round performance, but a very, very large type of gear. So the next one up, and the largest we can go up to, is the ZP series machines. Now, these are really big machines, especially when you're going up to gears of 8 meters. And I will show you a little animation in a bit of these 8 meter machines. So again, we can do internal, external machines on these, gears on these, and we can also produce them to very high quality. Type of gears that might produce on this are those that are used on wind turbines, and again, some very large earth moving machines. So next, if we look at the VX series machines. So the VX series machines, again, we can do internal and external gears on these. We can cut straight gears, helical gears. They're very, very versatile. The other thing on a VX machine, and this is why they're quite often used in aerospace, is it's profile grinding, so it's high quality. But we've also got the facility on this to be able to grind multiple gears in one setup. So where we have something like a shaft with 3 pinions on it, that can be machined in one setup on the VX machine. Okay, and we have these in certain aerospace producers in the West Midlands area. So it's a very, very proven and very high quality machine. The RX machines, these are specific to either rotors for pumps, compressors, or ball screws. That's all these particular machines are designed to do. Pretty, what's the word I'm looking for? Quite a small market, but we do have those within the portfolio as well. So the ZP machine, the ZP80 that I mentioned earlier, this is the big gear machine. So this is just to give you an idea of what they actually look like and how big they are. So really, it's a small house rather than a gear than a piece of engineering machinery. As you can see, it opens fully up so that any parts that are there can be craned in. And as it says on there at the end of that thing, it is pretty unique as a product out there in the marketplace. But I think finally, sorry, before we move on, we then have the gear centers. So the gear centers are the maximum flexibility that Kapp can put within their machine. So with these machines, we can do generating grinding and profile grinding. We have high-end productivity in terms of the quality of the gear that's produced. We can do internal grinding and we can do external grinding. So they have total versatility. The other thing with these is the ease in which you can swap from one process to the other. It doesn't take hours and hours. It's a fairly quick process in terms 20, 30 minutes to change from profile grinding to generating grinding, from internal to external grinding, etc. The KX Flex machine is the most flexible machine, even by the ZX standard. This is taking it to the next level. So we can now, not only with this machine can we do internal, external, etc., profile grinding, we can also now grind gears which have interfering edges. So in other words, where you have what we call a herringbone gear, so 2 helix angles on one gear coming from opposite directions, we can now machine gears such as this on the Flex. So the Flex machine is the most flexible machine, as the name suggests, in the marketplace at the moment. There's certain patents on there which Kapp have, which means that nobody else is going to be copying that too soon. And it really is such machine that some traditional profile grinding customers are now starting to look at, because it gives them the flexibility to move into different markets. So industrial sectors that operate in aerospace, which I've mentioned on several occasions, we have several customers in the UK. Aerospace, automotive, Kapp have machines in a lot of the usual automotive suppliers such as Audi, BMW, etc. And that's where the majority of the generating grinding machines, the KX machines, are in place. A lot in China as well for those particular markets. With agriculture, you've got some of the big tractors, etc., and combine machines. So you're getting up to some of the big gears, 800 centimeter gears that you can be putting into those sort of machines. And then when we come onto the mining, you're talking at the 1.2, 1.5 size machines. The other industry in the UK, which we have lots of machines in, is the drive and motorsport area. So companies like Xtrac and Hewlin have several Kapp machines, all based around the profile grinding technology because of the quality of the gears. But that's one of the strongest areas that we have in the UK. Worldwide, all of those markets are covered within the Kapp portfolio. So, why Kapp Niles? As I mentioned before, they're a world-leading brand. They sell over 140 machines on average every year across the world. They have a range of machines, as I think I've just shown you, which goes from the smallest, highest level production machines up to being able to produce massive 8-meter plus gears. They have industry-leading reference customers. Now, a lot of the customers that Kapp Niles are in, I can't really share on this presentation because of NDAs, but if you want me to give you a list of those privately to talk to your customers, then I can do that. The machines are high-end accuracy. We can produce gears to a DIN 1 standard. So the DIN 3962 standard is the German gear standard. DIN 1 standard is what we call a reference gear. So this is top quality gear. Give you an idea, gears in your car would be somewhere around about a DIN 6 to 7 standard. So we can produce top-end gears. The reason they do this, they still hand scrape guideways on the machine, which gives the machines great accuracy. And as I mentioned before, every machine has in-machine measurement. So as a gear is being produced, we can check those gears before they come out of the machine. The Kapp machines are ergonomically designed. So for manual loading, we have the facility, if you need, with the ZE machines, for example, they tend to be with the work area about waist height for people to be able to load and unload. And those that are slightly higher, they put steps on those. So again, people aren't having to lean into the machine to load the parts. Crane loading and unloading is also available with machines. Easy tooling change, and the KN grind software, which is now coming onto the machine, which is very, very easy to use. Finally, I mentioned before about the introduction of metrology and how Kapp can become a turnkey solution. We can now offer the machine, we can offer the metrology, so that's the gear measurement. We can offer the tooling, the tool management, and within that, they can now offer with the KN grind software a closed loop system. Now, what do we mean by a closed loop system? So in gear grinding, closed loop system, so using the KN grind technology, we have the machine. So we grind the machine, we grind the workpiece. So we grind the workpiece, and each workpiece is given a QR code to identify it. We're using the Kapp gear measurement machines. We import the measure program to the relevant information to the gear that we're measuring, and we can bring that gear across then to measure it on the gear measurement machine. Once we've measured that, that is then stored in the file as a GDE file. Now, GDE file is a gear data exchange file, which can then be fed back into the machine. So once that data is fed back into the machine, we've taken the sample gear, we've tested that on the thing, on the gear measurement machine, we've fed the GDE information back into the machine. What the machine can then do is automatically correct the production to take out any deviations. Now, there is an error on this slide, but it's Kapp's own slide, so I've not been to change it. So it should be the deviation is outside of the predefined range. So where we have a deviation outside that range, the machine will automatically adjust the process to compensate and bring the workpiece back inside that predefined range. So that's what we call a closed loop system with a KN grind system. So you can see that Kapp is now a full turnkey solution for someone's grinding needs for gears. What sort of information is useful for us to find out from a customer who may be interested in talking to us about gear grinding? Some quick questions that may be there. Size of the parts, the diameter of the parts, and the module. Now, the module of the part, a little calculation down here, is basically the diameter of the part divided by the number of teeth. It's something you'll see on the slides previously. We mentioned each machine, the gear module. That's what a module of a gear is. Okay, simple piece of maths, but it's one thing that the engineers ask for. Volume, parts per week. Is it high volume, low volume? So we start to think about whether or not it's generating grinding, or if it's low volume profile grinding. Do they want internal or external gears, or both? Drawing of the parts, the material, the type and hardness, and whether or not there's any automation within there. So those are the sort of things that are useful information to bring back before we talk to the customer about gear grinding. So just to finish on, I'd just like to run a quick video which shows the KN 350 machine, and it shows it's doing generating grinding, but it shows the processes that we've just been through within the presentation. So it just shows you the KNG 350 machine in operation, profile grinding, but also how easy it is to change the tooling, and a bit of the closed loop system in terms of the gear measurement. So that's it for gear grinding. Thank you for your attention, and any questions?
That was really good, Mark. Thanks a lot for that.
Okay.
There's a lot goes into a gear. Okay, so we take it for granted, I think. So I'm going to unshare your screen.
Yeah.
Excuse me. So
where do I get that to? Where is it?
Oh yeah, I'll do it for you, shall I?
Yeah.
There you go.
Well, thank you.
So chat's open, guys. Anyone got any questions for Mark regarding gear grinding or Kapp Niles? No questions again. Derek, where are you? Oh, yeah.
Steve Brown's got one, has he?
Yeah, Derek will always have one. That's he's old faithful, isn't he? Go on,
Still
Derek.
learning, man. Still learning. Fair play, Mark. Thanks so much for that. Very good.
Thank you.
Mark, is there different types of grinding wheels for different materials?
There's different types of grinding wheels in terms of the fact that you've got your dressable wheels are CBM, your non-dressable wheels are diamond or diamond abrasive. That's it. There's no real difference between for different metals. Okay. It's you've either got your dressable and non-dressable. What you can do is different grips of material. So you can have a finishing wheel, a grinding wheel, and a finishing wheel. And they've now started to introduce a thing called a trio wheel, which actually has your grinding wheel, your medium grip wheel, and your finishing wheel all built in together. So there's different types of wheels from that point of view, but not for different materials.
Yeah. All right. Thanks, buddy.
Good one, Derek. Steve Brown.
Good one, Mark. Well done, mate. Again, I've got limited knowledge on the gear side, but is Kapp Niles, is it always gear cutting? You know,
Grinding.
Gear grinding rather, because you look at some of those elements. You know, we get involved with the aerospace part. If you know the fir tree root on the bottom of the blade, that seems like a similar process. Do they get involved with that element as well, or is it always gears?
No, it's always gears. They do some special profile machines for, as I say, for rotors and stuff like that. But no, the rest of it is gear grinding, Steve.
Got to be a gear.
Yeah.
Right. Cheers.
Gordon Coates, you've got a question.
Hi, Mark.
Hi, Gordon.
On your first slide, there was a reference to helical gears and then something called a screw gear, I think it was.
Yeah.
What's the difference between helical and screw gears?
It's to do with the angle of the teeth. The helical gear, trying to how best to describe this. Without drawing it out, it's very difficult to describe.
I understand what the helical gear is, but I was looking at the screw gear and thinking, well, what's the difference between
it's to do with the tooth angle and the way they mesh. The helical gear, as I said before, has got a slight angle. The screw gear has got more of an angle in it and the way the teeth mesh. But without it's...
Okay, then where would a screw gear be used as opposed to a helical gear?
So the screw gear, as you saw on that, will change direction. The helical gear, you've got very, very parallel drives on it for that, unless you start to get it with double helical. With the screw gear, you have got almost a right angle change of direction.
Okay, thanks.
That was a great answer. Be on my phone, my friend. Scott.
Yeah, great presentation, mate. I had no idea they went so big, to be honest. Mark, obviously there's a big range of machines there. But if we were to talk about, let's just say gear manufacturing in automotive, something like a gearbox, external gears, what sort of price bracket are we speaking about for something like that?
Okay, so when you say automotive, are you talking about, and I've got my price list here, so
I'm not going to buy one.
So if you're talking about automotive in terms of, let's say, Audi, BMW, etc., where you're producing a mass amount of gear, so you're looking something like what made of the KX models, yeah, so with the conveyor loading, etc., you'd be looking best part of €1 million.
Okay.
No, if you look at the machines, for example, that are currently in extract, okay, so where they've got KX machines in there and VX machines in there, again, you're looking with the necessary tooling, again, not far off the best part of it. In fact, the last machine that went into extract was 1.2 million, including the tooling and everything, euros. So that's where you're looking at in terms of that for high end. So volume manufacturing for automotive, round about €1 million. High precision production for top end motorsport. So that's your F1s and your extract type people, again, round about €1 million.
And what sort of lead time were you looking at from let's say, order to delivery?
Around about 8 to 10 months.
Okay, no, thank you very much.
One of the things on that, Scott, I did mention as part of it, and this is something that they still hand scrape the guideways at Kapp. So one of the things they struggle with is getting people to now train to hand scrape guideways.
Yeah.
So one of the problems they have for lead times on product is not having enough people to hand scrape guideways to produce the machines.
Okay, thank you.
Thank you, Scott. Graham Thomas, you got a question?
Hi there, Mark. Great presentation. Thank you very much. Yeah, my question is just interested, how many of these machines are actually in the UK, and what would you expect potentially being a good year on how many you would expect to sell in the UK market?
Okay, so within the UK at the moment, there are roughly about 15 to 20 machines in the UK. Maybe, yeah, I'd say nearer 20, around about 20 machines in the UK. On a good year, the UK market is 2 to 3 machines. An average year, probably 1 machine a year. As things stand at the moment, and I don't want to, obviously with everything that makes it a bit difficult, but we've got several projects running live at the moment, Graham, because a lot of the current machines are coming to the end of their life. So they're no longer supported by Kapp. So we've got machines in Wolverhampton at certain aerospace manufacturers, shall we say, that are now not supported. So they're now in the process of looking at, do they replace or how do they go? So yeah, but normally a couple of machines a year would be a very good year for the UK.
Okay. And is there any major sort of competition to Kapp in this particular area that is very competitive?
Yeah, you've got places, people like Gleason Fouter, Lieber. You've also got Klingenberg, which are all competitors. So Gleason are probably one of the main competitors. One of the things that you'll find with the Kapp range compared with the competition, they tend to be more into certain markets, like Lieber, for example, are very much into the automotive market, but are not so strong in the aerospace market. Whereas Kapp have got a very wide range of products across the whole market. And now having the metrology side as well, which is a different presentation for another day. There's a whole area on that as well. They now become very much key players in the market. And as I said with that last part, the turnkey closed loop system is going to take them forward now as well.
Okay, that's great. Thanks, Mark. Cheers.
Good question, Graham. Steve Brown, should I answer that? Steve wants to know if we should have any in stock.
Just the ZP80s, that'll be it.
Yeah, that'll do. Right. Get a couple of them in.
We could just use it as a warehouse.
Kieran saying, well, first of all, Jamie, are you there?
Yeah.
First of all, mate, what you need to do using your time at home is just teach Kieran how to spell question.
That was me that wrote that. That's even worse.
Right. I'll play him at Scrabble.
No, that was me that wrote that. Sorry.
Oh, okay.
Yeah, Mark, just you mentioned there that you do machines for ball screws.
Yep.
So I take it that's the actual ball screw itself. Do they do machines for the nuts? Ball screw nuts, the housing?
No. It's simply the machine for they do the machines for the pumps and the drives and ball screws, but not for the nuts. It's simply for the ball screw. What's the word I'm looking for? The shank. No, not the shank. What's the word I'm looking for? Shaft. That's it. Yeah.
Sorry, yeah.
Yeah. So
okay.
It's for machining the shafts, Jamie.
Okay. Thank you.
Good. That was a great one, Mark. So thanks very much. No more questions for anyone?
I would just say, I'm Graham. I know I mentioned it to Graham earlier, but when I was first taken to Coburg, they did take great pleasure in taking me into the town square and boasting about how they had the largest Prince Albert in the world. Not knowing what our take on a Prince Albert is compared to what theirs is.
Yeah. Derek actually has got one more question. Go for it, mate. Derek? Unmute yourself, mate.
Yeah. Just as I was emailing you there yesterday, Martin, would it be possible for all the lads that did the presentations to maybe share all the slides, just for reference?
Yeah, a good shout. What we'll do is once we finish when we got through a few of them, I'll get everyone to send in their presentations to me, and I'll zip them up into a nice package and send it out to everyone, because like you say, it could be pretty handy for you guys to be using out there on the road and stuff.
Nice.
Yeah, not a problem, mate. We'll sort
Thank you very much, fair play.
Yeah. Okay. That's it then. You're out of questions. Well done, Mark. I'll let me unmute everyone. Give you a clap. Well done, Mark.
Good stuff. Well done.
Well done, mate. Well done.
Well done. So, okay, so like I say, what we'll do is, no one's got any more questions, have they? No, can you hear me?
You might want to mute everybody, I think, because...
Is that it? Have I done it? Yeah. So, yeah, what we'll do is we'll change the running order. We'll have we'll do Steve Howes and Nakamura software on Thursday, but I'll send out a new note with with the running order. Okay.
Oh, Mart, are you not doing a daily fact today?
Fun fact.
Yeah, you've been doing fun facts. You're not going to do one today?
I can do them every day, yeah. Fun facts. What do you want it on? Gear grinding or Kapp Niles? Okay, so Kapp Niles, here we go. Now, what I know, Kapp Niles, that if you was playing Scrabble and picked out the letters that spelt Kapp Niles, i.e. Kappniles, and you was the first one to put them down, then you wouldn't be able to get rid of all 9 letters all at once, because there's no word that exists that contains all 9 letters. Now, you could have an 8-letter word, which would be ski plane, which is obviously an aeroplane equipped with skis for landing on or taking off from the snow. And that's actually spelt with no gaps as all in one word, but you'd be left with 1 L. Will that do?
I don't know whether you're just really good at making that up, or I believe you.
Well, I bet you go Google it. You tell me tomorrow if you can come up with a 9-letter word that contains all of Kapp Niles, Kappniles. I reckon in my head, the best one you'll get is ski plane. I'll leave that one with you. So I'll send the new invites out and all that tomorrow. We'll start again on Thursday, all right? Thanks again, everyone. Have a good evening.
Cheers, mate.
There you go. Thanks, Martin. See you, lads. Take care. All this.
Bye.